Hi, Algebra 2. So I wanted to come back behind our class meetings from today and give you guys a few more examples, a few more notes on solving inequalities. I'm going to pick up a couple of the examples that were used from the CK12 assignment and a couple from the quizzes. But I also wanted to go back and kind of lay some of the groundwork when we think about solving inequalities. So we've been working with equations, okay? Same value on both sides. In dealing with inequalities, we do not have the same value on both sides. One of the items is going to be greater than the other or less than the other. So we have less than or equal to, greater than, and greater than or equal to. And we also use this symbol to represent not equal. It's pretty rare that you see that in an equation in algebra class, but you may run into it into some other situations. So we've got these symbols, okay? And we read these from left to right. Whatever's on the left side is less than the thing on the right side, okay? Sometimes we end up with the variable over here, and we'll see what happens with that momentarily. So first, let's take a look at a couple of examples. So this one came, I think, from one of the quizzes. So 17 is less than or equal to x over 2 plus 11. So this is a two-step inequality. We have a variable, it's divided by 2, and that quotient has 11 added to it. So we're going to save the variable term for last. We're going to undo adding 11. So we recognize that to undo addition, we're going to subtract. 11 minus 11 is 0. So on the right side, I have x over 2. The left side, 17 minus 11 is 6. So now 6 less than or equal to x over 2. X is divided by 2. How do we undo division? That's multiplication. So 2 times 6 is 12. X times 2 divided by 2. Well, 2 divided by 2 is 1. So the right-hand side is just x. And so I end up with this. This is a totally legit answer. If you leave it like that, it's fine. If you get asked to graph, right, or you get asked to read this, we have some things to think about. Possibly in middle school or maybe in Algebra 1, when you were graphing inequalities, you might have had a teacher or a classmate tell you that the inequality sign points the same way as the arrow. Well, that only works if the variable's over here, okay? So if we start from x, we have to read this going backwards. If 12 is less than x, then x is greater than 12, okay? If you think about these two on a number line, here's x. If 12 is less than, it's somewhere to the left of where x is. So if we started from this side, what would we say about x? It's greater than 12 because it's to the right of 12 on a number line. So we would write x greater than or equal to 12. And if we were going to graph it, it's probably a good idea to write it like that. All right. So that gave you kind of a look at a two-step inequality, which is one little hook to it, right? That we ended up flip-flopping the x and the 12. Let's take a look at this guy here. This also was one of our quizzes problems. So we recognize we're going to add 1 on both sides. Negative 9a less than 26 plus 1 is 27. All right. So a is multiplied by negative 9. So I'm going to divide by negative 9 on both sides. Negative 9 divided by negative 9 is 1. 27 divided by negative 9 is negative 3. Now, because I multiplied or divided by a negative number to isolate the variable, the inequality sign changes direction. So a is greater than negative 3. So let's look at another. 11 greater than negative 3y plus 2. So you can see we've got a similar situation to what we had in our number 1. Our variable's on the right side. So we'll deal with that towards the end. First, though, I'm going to isolate my variable term, subtract 2 from both sides. 11 minus 2 is 9. And so now this is kind of a combination of these two examples, right? Divide by -3, divide by -3. So I can see that my sign is going to flip. So you could say -3 is less than y, or y is greater than -3. Either one of those is legit. All right, and one more example. We're going to amp up the level of difficulty on this one a little bit. So we've got a multi-step inequality. We've got to resolve distributive property here. So most of us, I think by now, we've been doing distributive property since 5th grade. So we see this and we're going to say 3 times m is 3m, 3 times 7 is 21, and then less than 28. Okay, so just like previous, I have 2 steps to undo here. I'm going to save the 3m for last. Let's subtract 21 to undo adding 21. So 3m is less than 7. Okay, now I'm going to divide both sides by 3. The left side is just m. Now here, you've got a couple of options. It's totally fine to just leave this as a fraction. M is less than 7/3, and it's perfect. If you did go ahead and put that in your calculator and put 2.3 bar, that would be fine too, right? But one of the things that we want to get comfortable with, I guess, is working with the idea of fractions without always going to put them in our calculator. Eventually, as you guys recall from Algebra 1, we end up working with some polynomial expressions, some algebra expressions that contain fractions and variables, and we have no way to simplify those in our calculator. So I think the more comfortable we can get with fractions just in general, the better chance we have success down the line. So these are some of the examples from today's work worked out, and I'm hopeful that this helps you guys get a better handle on this idea of solving inequalities with 2 steps or multiple steps.